Okay, so I think just to kick it off, we're going to I'm going to go into the differences between NoSQL and SQL database, but we're going to do this in light of VSC. So when we look at VSC's design, this is just a small design. I know it's probably more detailed and more complex than this. Um, but when we look at the tenancy of VSC, you sort of have these categories that hierarchical kind of layout. So you start off with the network, and then each network has organizations underneath, and then each organization, of course, has students, and then you have parents and counselors that are assigned. And then when we look at the initial data behind it, we're storing scholarship information, student profiles, essays, and resumes, and different documents. We have case notes, we have college applications and scholarship applications, we have awards and aid that we track, we have office hours, and then we have activity and KPIs that we track on the admin dashboard. So all of this data is sort of making up what the VFC is storing. And then we're going to look at, what are the better formats. So based on this data that we store, what are some that are more suited for relational databases and what are some that are more suited for NoSQL databases. So the first thing we're going to look at is kind of this difference in querying your database between a NoSQL database and a SQL database. So we can imagine where we are running a search for scholarships for a first generation nursing student in Fulton County that are closing this month. So one of the things we would have to do is if we are writing an SQL statement, of course, is you'd have this statement where you'd say where name is like nursing, and then you would have to check for the major and then check for the county. But one of the things that we're not doing here is tracking things like typo tolerance, or we're looking for facet counts. So facet counts is basically a way that allows us to, when you filtered your data, you can get that filtered data and then add extra operations to it. So, for example, when we say where major is like nursing, it allows us to gives us that data object where you have all those um, majors that just match nursing, and then you can apply extra functionality to it. So things like getting the count, or you can pass that back into your database and do some extra queries with that. So one of the things I'm going to show right now is just the difference in how these queries would look like. So in SQL out of the box, we don't support ranking, there's no type tolerance, but a lot of NoSQL databases actually have this in built in. And so we'll just look at, this two different queries. So on the left, I have a SQL query, and then on the right, I have a MongoDB Atlas Search query that's running on an NoSQL database. So when you look at this SQL statement, the first statement, of course, is that we would need to install this package from Postgres, and this is what enables typo tolerance. So, for example, just going back to the slide, if you are to type nursing with the S and R swapped, when we have this SQL statement over here, it actually won't return any result. So we would have to enable that with this extension. And then from there, we can go and select our ID, name, major, and county from our database. And then we have to calculate some relevant score. And this is what we're going to use for ranking and typo tolerance. And then to enable that typo tolerant or fuzzy searching, this is kind of the statement we would write. And then you have your conditional filtering logic where we're looking for the county as Fulton, we're looking for a major as nursing. Um, and then this is where you would kind of have to write another statement based on this result, because these would be our filtered results. Now we want to get the actual documents from the database, and then we want to get some counts. That's another statement that we have to write for the major, and then we get counts for the county. And then finally, we combine all of these results into one JSON object. So you can see that there are multiple steps we have to write in SQL. So it tends to be a very complex query. But when we look at something like what NoSQL would do, is of course you have this search, which is our entry into the query that we're trying to run. You can define indexes just the same way we can do it in SQL, but here we're just using default. And then you can see it has this object where we run our query. It has this built-in fuzzy search for you, and then of course you can handle your optional conditional filters. So in this case, we do have these are conditional filters that actually have to happen, so they're not conditional. And then finally, you have your facet count. So we're trying to get how many majors are within our search query, and then how many counties are returned for the county that we had searched for. So you can kind of see there's this difference in running your queries between SQL and NoSQL databases out of the box. So relevance ranking, of course, is built in with your NoSQL database. And then your facet counts are returned with the results, so you don't have to write another query on top of it. And then we saw like things like typo tolerance are actually built in, and these queries tend to be extremely fast um, when they're running. Um, so moving on to the schema. So, like we said last time, relational databases tend to be very rigid with their schema, while for a NoSQL database, you kind of have this flexible schema that you look at. So, for example, we're looking at this scenario we have over here where a scholarship has multiple criteria, and we are assigning an ID to each scholarship. So you have scholarship one, scholarship two, all the way up to scholarship five. So anytime we are trying to add a new criteria for that scholarship, what would happen is that some of the scholarships would have empty fields. So for example, scholarship one, let me go back. Scholarship one has a minimum GPA and an essay word count, but it doesn't contain major, county, or first generation. And so this would actually return, would make us have empty fields in our database. And so this is very difficult to construct. And what that means also is that if a new provider, wants a new column for their scholarship, if we are having a SQL database, a relational database, that means you have to run a migration. So you create this new column, and then you update your table with that new column. But you're going to have a lot of these empty fields. But in a NoSQL database, you're basically having one document for each scholarship. So, for example, here you have this scholarship with ID S2. And then, if you can see, these two scholarships have actually very different um, results in them. So, I mean, underneath their criteria, you can see for this scholarship, we have major, and then we have county. For this other one, we have veteran family and essay. So, what this helps with is when you're adding a new criteria, you're just updating a field. It's not an entire migration in your database. And then these criteria actually travel with your scholarship. And one of the good things, this is, yeah, and we're just calling it, no, no, no. So it's not a reserved word, no. We've created criteria as a field that contains this list of criteria that can differ based on the scholarship. It's just the name we've assigned to the field. That's right. Yeah. But we're using it to just mention that you can see that the shape of each scholarship is different in this criteria field. Um, and so one of the good things of doing this is that first of all, you don't have these arrangement over here where your cells, you have some empty fields in your database. Um, and then the good part of this is that when we're returning these results, we don't have to care about these empty fields at the same time. Um, And so the scholarship is self-contained with all the information that it needs. It doesn't contain any of information that it doesn't require. Um, so you would create this on the fly. Because this is an object, I believe you can, there's a data type that we use to mention that this is going to be a list, but you don't have a strict schema of what is going to be contained in that list. So all we could say is that, for example, in our case over here, you have, this is kind of like a key value pair, a list of key value pairs. So you have some key and then it has some value. Yeah. Yes. Yeah. Yes. So it's going to be stored as a document. So when you're querying your database, it returns this. And guess in our case, we can convert this into JSON. And then this is what the client is going to read. But the challenge of this though is that the client has to be aware of what fields it's going to get back. So there is need for some kind of validation on the client side because, for example, like we've seen, criteria might have major and county for one scholarship, and then for another it could have that essay, word count limit. So your client has to properly manage those fields. Select star, yeah, and then that would return everything. That's right. Yeah. Yeah, front end, yeah. So the client has to be aware of that change. But what that means, the good part is that the scholarships that already work won't be affected. So you just have to worry about that new criteria or like new scholarship you've created that's, a little bit different from all the others. And then what some people can do, you can make your client dynamic. So since we know that criteria will always be this like key value pair, so you can make it traverse through all the keys, and then depending on what the value is, whether it's like a single value or it's another object, maybe a list, you could make your client optionally render that information the right way. So for example, if it displays a table where it has the scholarship ID and maybe all the criteria in that scholarship, what we could do is we can conditionally render and say, so if it's a criteria and maybe if it has a list, maybe get the first object and then render that. So that way your client also might not really need to be updated. Um, so there's some ways you could make your client where it's dynamic, just the same way that your database is. Hmm. Yeah. So I think moving on, we'll sort of look at consistency versus availability. And so when you look at SQL databases, they're primarily ACID. So atomicity, consistency, isolation, and durability. So what that means is that whenever you make an update to your database, every read is gonna reflect that every subsequent read is going to reflect that um, most recent update that you made. And so what that means is if you have a very big database, so you have your databases, spread across different partitions, um, your reads would have to wait until that update has propagated or has been updated to every file before you could actually get a response back. So reads can be slower if you're making a lot of updates. But what NoSQL databases are optimized for is your reads and availability. So what that means is that even if an update hasn't made it across your entire database or your entire storage, you could still receive reads even if the data might be stale. And so when we look at the VSC, there are some data objects that we need to be consistent. So, for example, things like application status, we wouldn't want a user to see a stale application status. So, if they updated the application status and said, "Hey, I've submitted my data," we always want to make sure that they see the most recent update. But for example, things like a dashboard counter, where maybe we're counting the number of logins, we are fine if that data lags behind even by a few milliseconds or sometimes even minutes. We don't really care so much about it being the most recent data. So things like counters or scholarship search, for example, if a user has 400 scholarships that match them, or 412 in this example, and then later on our database runs that query again, and then maybe that jumps to 500. Even if they see 412 temporarily, that's going to be fine, um, because we don't really care about that being the most recent update. So this is kind of where we can begin to see that difference between where we can apply relational databases and where we can apply like NoSQL. Um, and then I think maybe this is the last point I can talk about. So VSC is multi-network in its design. So in this example, I kind of have four networks over here. So we have one for Fulton County, one for DeKalb County, one for Cobb County, and then we have another one that's just serving rural Georgia. So what this means is that most of the time when we're having a read, reads usually go by network. So very few times do you have reads that are reading from multiple networks at the same time. So when I log in as a student, I'm mostly under just one particular network. So what this means is that this is a very good use case for using a NoSQL database, because they come in with they're optimized for partitioning. And so the good use case for this is when it comes to that horizontal scaling, we can actually scale by network. So, for example, if we look at the numbers over here, rural Georgia has about 800 students. So it would be fine if we just had them running on one stack of machinery. So running on just one node or one compute, because the numbers are few. But we can imagine, let's say, for some, maybe, the Scholarship Academy gets a new contract with maybe some organization that wants to serve Fulton County, and then this number doubles from 18K to 36K. What we can actually do is we can partition, because our database is partitioned by the network. What we can do is we can scale based on just this network that serves Fulton County. So all these other counties or networks might just have one node that's running, but for the sake of Fulton County, we can maybe double that or triple that so that we can serve the amount of traffic that's coming based on network for just Fulton County. So this would be a very use case for applying that partition key inside of a NoSQL database. Mhm. Yeah, I think we're at time, so I'll close it out here, and then we can. I think by Friday we should be able to wrap this up.